Hi everyone. If you're watching this video, there's a pretty good chance that you are at least a little bit familiar with the SAMD51 microcontroller. The SAMD21 has been used on some popular Arduino boards, such as the Arduino Zero, and also the Arduino MKR0. What if you want to make an application with the SAMD21 that needs to connect to Wi-Fi? Well, they have you covered. You may also be familiar with the ATWINC3400, which is a Wi-Fi module that is often used together with the SAMD21 microcontroller. In fact, both of these are actually paired together on another model of Arduino, the Arduino MKR1000 Wi-Fi. What many people aren't aware of is that each of these products, the ATWINC1500 Wi-Fi module and the SAMD21 microcontroller, have a cousin that is supposed to be newer and better. These are the ATWINC3400 Wi-Fi module and the SAMD51 microcontroller. The ATWINC3400 is very similar to the ATWINC1500. The biggest change is that it also supports Bluetooth, including Bluetooth Low Energy. The SAMD51 contains a more powerful processor compared to the SAMD21. It's faster, and it also contains more memory. Atmel, the guys who originally made the ATWINC1500 and the SAMD21, originally supported both of these products with the Atmel Software Framework development kit. Specifically, it was version 3 of the Atmel Software Framework. Eventually, Atmel decided that they wanted to build a new version of their framework, called ASF4, or Atmel Start, and they still supported both the ATWINC1500 and the SAMD21 in the new version of the software framework. But when the ATWINC3400 and the SAMD51 were released, someone at the company must have missed a memo. They made a horrible business decision. For some reason, they decided to only support the ATWINC3400 with version 3 of their framework. Meanwhile, the more powerful SAMD51 microcontroller was only supported with version 4 of their framework. This made it difficult to build applications using these two products together because there was no documentation or support for doing so. I recently adapted the ATWINC3400 software library to work with Atmel Software Framework 4 so that it can be used in conjunction with the SAMD51 microcontroller. I've posted the ASF4 version of this library to a GitHub repository that I will link in the description below. In this video, I will do a brief demonstration of how to use the ATWINC3400 with the SAMD51 in ASF4, also known as Atmel Start. Before getting started, it's important that for whatever board you're using, you need to have a certain set of pins defined. Here I'm showing what pins I am using for interaction between the microcontroller and the ATWINC3400 Wi-Fi module on my board. These pins will likely be different on your board. Make sure you have your schematic figured out and your pins decided upon before continuing. Let's go ahead and get started. First, navigate to Atmel Start in your web browser and click on Create New Project. Now go ahead and find your SAMD51 microcontroller in the list. I'm using the SAMD51 P19A. After selecting your microcontroller, click Create New Project. Now the first thing that we want to do is configure our clocks. The clock configuration is going to be similar to how I've configured clocks in previous tutorials. First, enable clock generator 1. Then, select the 32 kHz ultra-low power internal oscillator and close. Now enable the digital frequency locked loop and configure it. Configure it to use clock generator 1 as its reference clock source. You can now disable the external crystal oscillator, and let's configure clock generator 0 to use the digital frequency locked loop. We now have our CPU clocked at 48 MHz. Now let's go ahead and add the Wi-Fi component from the middleware menu. Click Add Components. You'll notice that we have an SPI instance and an external interrupt instance, both clocked at 48 MHz. Now go ahead and return to the dashboard. We now need to select the pins that we are using for each of these modules. First, go to the SPI instance. For my board, we are using PB29 for the meso pin. I'm going to select that pin here. And then for MOSI and the SPI clock, we're using PB26 and PB27, which have automatically been selected for us here. Select the pins that you are using on your board for this SPI instance. After selecting the pins, there's still a couple important things that we need to do for configuring our SPI instance. First, go down to the baud rate, and instead of the default, which is 50,000, select a baud rate of 4 million. You may be wondering why you need to select 4 million as the baud rate for SPI communication with the ATWINC3400. There's not a lot of good documentation about this. In fact, there's zero good documentation about this. But I did find one support article online that describes how to select a baud rate in Atmel Start. Also, if you select the ATWINC1500 example projects in Atmel Start, you will notice that they use a baud rate of 4 million. Therefore, it seems like that is probably the baud rate that they expect you to use. But when you look at this example article, you will notice that they have an equation. And this equation is what determines what is a valid baud rate for SPI communication with this module. Notice that this SCBR component of the equation must have a value between 1 and 255. If you insert a value of 50,000, which is the default baud rate, into this equation, and then use a 48 MHz clock with that 50,000 baud rate, the value of SCBR will be out of the valid range. It will be 960 will be the value of that, which is not within 1 and 255. However, if you insert a baud rate of 4 million into this equation and still use a 48 MHz clock, now the value of SCBR is 12, which is in the valid range from 1 to 255. So we know that the value of 4 million should be a valid baud rate because it meets the criteria established in this equation, and it's also the baud rate used in the ATWINC1500 examples. Now, go to Advanced Configuration and enable it. Make sure that the dummy byte is not 1FF, but rather 100. This is important If you don't do this, the communication between your microcontroller and the ATWINC3400 will not work. After finishing configuration of the SPI instance, let's now configure our external interrupts. For my board, I'm using pin PA02 for my interrupts, coming from the ATWINC3400. This is on interrupt 2. Make sure to select the correct interrupt signal and pin depending on your board and schematic. After selecting the interrupt, go down to the interrupt settings corresponding with the interrupt that you are using. Enable that interrupt, and then make sure to select falling edge detection. We've now finished configuring the interrupts. Now select the Wi-Fi 0 module. You'll notice that it says we're using the WinC1500. Don't worry, we are going to be using the WinC3400, but obviously that is not an option in ASF4, so leave it like that for now. We'll fix it later. We need to select our chip enable, chip select, and reset pins. For my board, the chip enable pin is PB07. I'm going to find that in the list and select it. For my board, the chip select pin is PD01. And the reset pin is PB05. Select the corresponding pins for your board. After you've selected these pins, let's go ahead and rename our project. We will call this SAMD51. I'm going to call it SAMD51 P19A just to correspond to the SAMD51 that I'm using. You can name this anything you want. But I'm going to call it SAMD51 P19A ASF4 WinC3400. Now go to Export Project and click Download Pack. After downloading the pack, import it into Atmel Start. Choose whatever project name you would like and a location where you want the project located on your computer, and then click OK. After you open your project in Microchip Studio, you will notice there is a folder called WinC1500. That is the library for the ATWINC1500 Wi-Fi module, which we will not be using. We will be using the WinC3400 Wi-Fi module. You will need to sync the WinC3400 GitHub repository, which I have linked in the description of this video. In that repository, there is a folder called WinC3400. Copy and paste that folder into your project structure. Now, in Microchip Studio, you will see that in the Solution Explorer, there is an icon that says Show All Files. Go ahead and click on that icon. You will notice that you can now see the WinC3400 folder. Go ahead and right-click on that and say Include in Project. The WinC3400 folder is now included in our project. Now let's go ahead and exclude the WinC1500 folder. If you right-click on that and click Remove, you can choose to either just remove it from the project itself or completely delete the files from your computer. It really doesn't matter which one you do. Go ahead and choose one of those. After this, you can now unselect the Show All Files button. Go ahead and now save your project. There is now one more thing that we will need to configure in the WinC3400 folder. If you navigate from the WinC3400 folder to the BSP folder, and then inside of there into the source folder, go ahead and open up the nmbsp samd51.c file. You will notice that there is a definition called conf winc ext int pin. This is the interrupt pin used by the ATWINC3400. We are using on my board pin PA02 for interrupts coming from the WinC3400. This could be different on your board. Go ahead and define whatever pin you are using on your board for the interrupt pin. The pins, as you defined in Atmel Start, can be found in Atmel Start pins.h. And here you can see that for me, I have the pin PA02 defined. Next, you need to remove the WinC1500 folder as an include directory in your project. You can do this by right-selecting your project file and selecting Properties. Then go to Toolchain and select under the C compiler the directories. Here is a set of include directories in your project. You'll notice that at the bottom, WinC1500 is listed. I actually don't recommend using Microchip Studio to remove this include directory and then add the WinC3400 as an include directory. Anytime I've done this in Microchip Studio, it has caused it to crash, but you can certainly try. I recommend opening your project file in an external text editor and making the changes there. I prefer to use Notepad++. So in a text editor of your choice, go ahead and search for all instances of WinC1500. You notice that there are quite a few of them, but there's only really a few that matter. Go ahead and go down here to this set of references to the WinC1500. This is a reference to an include directory. Let's go ahead and change it to WinC3400. And let's go ahead and do that for this entire set of references. After changing that set of references, save the file. Return to Microchip Studio and select Reload All to reload the project file. At this point, we're ready to write an application that uses the WinC3400. Let's go ahead and just write a very simple application that connects to a Wi-Fi access point. We'll go ahead and include a couple of standard libraries. And we'll include the WinC init file, which was provided for us by Atmel Start. You'll notice that here in the Wi-Fi init function, it does some very basic initiation of the Wi-Fi library. Now, what we're going to need first is a Wi-Fi callback function that will handle any messages sent to us by the WinC3400. This Wi-Fi callback function follows a standard format, and you can see examples of a Wi-Fi callback function in several of both the WinC1500 and WinC3400 examples provided by Microchip in both Atmel Software Framework 3 and also Atmel Software Framework 4. Here, we're not going to create a very large callback function. All we want to know is if the Wi-Fi connection state has changed. If we get a message saying that the connection state has changed, let's go ahead and grab the parameter or the message that was sent to us. And then we can do some simple logic just to see if we actually were able to connect to the access point. Or we could handle a scenario in which we were not able to access or connect to the access point. Now, in our main function, let's go ahead and write some code that connects to an access point. The first thing that we need to do is just initialize the Wi-Fi framework. So to do that, let's go ahead and declare a t-string Wi-Fi init param. We'll just call it param. And we'll go ahead and initialize it to be empty. And now set the callback function to be the callback function that we created. Now go ahead and call the Wi-Fi init function using that parameter. Okay, next, let's go ahead and define a Wi-Fi access point and password that we're going to connect to. Here we will define Wi-Fi SSID as whatever your Wi-Fi access point is called. We'll just say your network ID for now. And then define a password. And whatever the password is to connect to your Wi-Fi network, we'll just say your Wi-Fi password for now. Now go ahead and go back to our main function. And let's define t-string network ID and a t-string auth PSK object. And now we will go ahead and just initialize those to be empty as well, similar to what we did with the param. Oops, we don't want a comma there. Okay. Now after we initialize those to be empty, let's go ahead and set our network ID channel to be any channel. And then the SSID, uint 8 pointer, and then we'll set the length of our SSID. Now let's go ahead and set everything for the password. And at this point, let's go ahead and attempt to connect to the Wi-Fi network. And you can choose to have it save the credentials or not. I'm just going to tell it to not save the credentials right now. Then go ahead and pass along your network ID and the password. Okay, now we just have one thing left to do, and that is to process any messages coming back from the ATWINC3400. So go ahead and, in your endless while loop, create another while loop that just says, while M2M Wi-Fi handle events, pass null into there, does not equal M2M success, and that can be empty for now. Okay. At this point, you can go ahead and run your application. If you want, you could set a breakpoint just right there. And whenever your application successfully connects to the Wi-Fi, you'll hit this breakpoint and you'll be able to identify whether it was successful or not. So that's it. You should now be able to use the ATWINC3400 in your projects. Specifically your ASF4 projects that you've configured with Atmel Start. If you have found this video to be helpful, go ahead and like the video, subscribe, and feel free to comment. Definitely if you have any questions as well.